Okay, so now we're going to try a zero span sweep, which will be basically a time sweep. And now what I'm going to do is I'm going to turn down the bandwidth so that I can fiddle with the knob. See if I can figure out, okay, so that's clearly going up, so I'm going to optimize this one down a little bit. Oh, I've hit the optimum. So now let's adjust the attenuation a bit. Of course, the annoying thing is that the attenuation is going to also change the phase. Okay, this is actually pretty fast. Now how stable it is in time. Now I'm turning the knob backwards. Now we've got about, our reference level was somewhere like 20 dB, so this is pretty good. We're getting 60 dB. But it's drifting. That's me pushing on the cable. Yeah, now you can see why carrier cancellation is a pain. Let's see if I can get this better. Oh, I'm at the minimum. Let's go back. So you can see this is then me tracing out, going through the minimum with respect to phase. This is me just turning the knob in one direction. Okay, let's turn the knob back the other direction. See my finger? Now, when I get that better, what we want to do is adjust this guy a little bit, I think. And of course, the problem is that I'm also adjusting the phase when I adjust the knob. There's really, I can't get it back as good. What a nightmare. Down a bit more. Down a bit more. Oh, I don't know if I've crossed the phase or the, so let's get to the minimum. It's like focusing an electron microscope. The best spot, and you fiddle the other knob. Yeah, I can get a little bit better now. It seems to be drifting in time. Now I go back and it's not the same. Oh, there we go. There's backlash on the gears, also a pain. Oh, I've gone too far. It's really like focusing the SEM. Oh wow, ooh, look at that. Let's just look at this for a while and see how long it's stable. And that's in principle not super impressive, that's 50 dB. And our target is 60. Now if I fiddle any one of these cables, game over. We just lost another 10 dB. Fiddle that cable, game over. The question is that just a phase shift or an attenuation change? Let's check it out. Sweep the phase, which is a relatively fixed phase, not attenuation dependent. Yeah, I see what's happened actually when I fiddle the cables. It's not so much a phase shift as an attenuation change, because I can't reach the same spot again using the phase knob. So let's try the attenuation knob, which has this annoying correlation with the phase knob, of course. Now I'm back. Oh, yeah, I'm back to my sweet spot. Can do better? No, I just missed it. This is really like 1 degree. This is basically the gears are barely moving the smallest amount I can make them move. This is a total disaster. Okay, I'm completely convinced that the way to do this is with the Michelson configuration. It's going to be a much better solution. The double phase shifter, splitter arm. Oh, jeez. Basically using phase shifters to generate attenuation is a much better idea. I can't seem to do much better than that. Let's just double check what our reference is. Yeah. Tricky. I've now just disconnected that to measure what our reference level is. Oh, 24, so I'm not really doing that well. Even in the best case scenario. And then even when I hit there, it's not stable in time. Grr.